Hey everybody, so I wanted to go through a little bit of lesson 9, give you a couple examples on how to get started on a few of those problems. So we're going to find that is in the Chemistry Remote Learning Materials folder, going into the tab for this week. It's going to be 5.4 to 5.15 assigned work, and then you're going to find the periodic table. I already downloaded that, so we can use that as a resource, and then you're going to click into lesson 9. So lesson 9 is a chapter about chemical names and formulas, if this loads correctly. So what you're going to do is you're going to read through this chapter. It's a little bit dense and it's kind of a lot in terms of how in detail it gets about naming and writing formulas, but it's a really good overview and it's sectioned in a way that is helpful when you're trying to go through the answers. If you're like, oh, I forgot that part of the lesson, you can go back and read that. But go ahead and read through this. You don't need to read every little thing. Like if you get to this, know that this table is your resource and it's not just like, okay, now it's time to read these. Lithium, like you don't have to remember that. That's always going to be your resource. I would just read the main texts and the main sections with the examples. But what you're going to do is numbers 1, 2, 3, and 4 at the very bottom of this section review. Okay, so as we're reviewing the section, we're going to be answering these. The significance of a chemical formula, that is told to you explicitly in one of the beginning paragraphs of this chapter. But now we're going to practice writing compounds, naming compounds, and writing the formulas based on the names in questions 2, 3, and 4. And I chose a couple examples that I think are going to be especially helpful. So here we're going to write the formulas for the compounds between the following. So I chose 2A, G, and H. So let's do 2A. 2A is aluminum and bromine, but it's going to be aluminum bromide. We know that aluminum, if we go to our periodic table, that's always going to have a +3 charge because it's in this family and group right here, and bromine is going to be here. It's always going to have a -1 charge as an ion. So to balance that out, we know that we have to have 3 bromines, 3 negative charges to balance out the 1 3+ charge in aluminum. So it's going to be aluminum, nothing there because we only need 1, and bromine, here we're going to have 3. All right. Moving on to 2G. So I chose a couple trickier ones so I can show you how to do those. So here's copper 2+, so that's going to be copper 2. And then this is a polyatomic ion here. So let's go to our polyatomic ions and see what that is. It was NO3-. If I can find it, here we go. NO3-, that's going to be nitrate. So copper 2+ and nitrate, and notice here that it's a minus charge, it's just -1. So the copper has a +2 charge and the nitrate has a -1 charge. So we're going to need 2 of these polyatomic ions, of these this ion with 2 atoms to balance that out. So let me show you how to do that. So copper 2, and that has a 2+. Now think of this nitrate as one single atom with a minus charge. That's why we're going to write parentheses around it, because we need to show that there are 2 of them. If there's ever 2 of these polyatomic ions, you're going to write parentheses around them. If there's only 1 of them, then all you're going to need to do is just write NO3. But because we need 2 of these minus charges, I'm going to add in a parentheses here, NO3. NO3, and then again another 2. So what this is doing is it's saying, hey, this 2 is related to all of this. That means we have 2 nitrates in this formula to balance out the single one copper with a 2+ charge. All right, now moving on to H. 2H, we have NH4+ and SO2-. So here we have 2 different polyatomic ions forming in an ionic compound together. Let's go ahead and look at their charges. So I see that this ammonium, NH4+, is going to mean that we need 2 of them to balance out with the SO4 2-. Okay, so we need 2 of these ammoniums, and then just one of these, right? So what we're going to do, we are going to write in parentheses, because there's two of them, NH, and then down for, we need two of them to balance out the 2 minus, two of these to balance out the 2 minus from the single sulfate, SO4 2 minus, so 2, and then SO4. Because these on their own are ions with charges, they should balance out, meaning that this whole thing as an ionic compound has a neutral charge. So 2 plus, 2 minus, that's balanced, we're good. So let's move on to number 3, going through a couple examples there. Naming the following compounds using the stock system. So here's how we're going to name it. We've been doing this in the lessons last week, so let's just dive in. Here, calcium oxide. Let's go to our periodic table and figure out what charges these things are going to make as ions. So calcium is going to form a +2 charge because it's in this family right here. And then oxygen is going to form a -2 charge. -1, -2, -3, -4, +3. So oxygen is going to form a -2, +2 cancels out with a -2, so it's just going to be calcium oxide. Oops, wow, I misspelled calcium. How about that? All right, so we named calcium oxide. All right, so now we are going to use, we're doing 3E, so that's copper and bromine. So copper, we know, can form multiple different types of ions. So this is really important. Let's find out what bromine is. So bromine is going to form a -1. So we know that if bromine's forming a -1, copper has to have a +1 charge. So copper, and then Roman numeral I, copper 1, bromide. Oops. Now for 3F, for example, there's iron, right? Iron also can form multiple different types of charges. We see that chlorine, there are 2 of them. Chlorine is also going to be a -1, so it's got to be iron 2 to cancel out the -2 charge from the 2 chlorines. Moving on to 4B, which formulas write the formulas for each of the following compounds. So 4B, lead 2 nitrate. So we need to know what nitrate is. Remember, nitride means that it's just a nitrogen, but nitrate is a polyatomic ion. So we know that lead has a +2 charge, and nitrate, we need to figure out what the formula for that polyatomic ion is. So let's go up to our polyatomic ion list. So lead 2 nitrate. Nitrate is NO3 with a single minus. That means that our formula needs to have 2 of these. If lead has a +2 charge, we need 2 nitrates, which means that would be 2 negative charges. So lead is Pb. You're going to use your periodic table for that. You're going to find lead Pb right here. And then because we need 2 negative charged nitrates, NO3, and then another 2. I'm working on a Mac. It might be easier to write this because the subscripts are really important, but for Mac, I press Command and then left arrow to go down to a subscript and back. So lead, that has a +2 charge, and then nitrate, one of these has a minus charge, 2 of them is going to have two negative charges, so that balances out. Let's check out 4E. 4E is going to be carbon diselenide. Okay, so this is what we get in a molecule with no metals. We have carbon and selenium. So let's find out where these things are. Selenium is right here, and we have carbon. Remember, di is a prefix meaning that there's 2. You're going to find those list of prefixes right here. Di means 2, okay? So if there's no prefix in front of carbon, that means there's just one of them. So it's going to be carbon, and then selenium is right here, and then we know that it's going to be Se, and there's two of them. Se, and then underscore 2. There we go. Carbon diselenium. So we just did 4E, and then F for acetic acid. That's hard if you don't know what this is, but thankfully we have a list of acids that we can refer to as a resource. So common binary acids and oxyacids. So acetic acid, if we're looking for it, we're going to find right here. So I'm just going to type that formula right there. We already know what it is, CH3 COOH. And that's acetic acid. Alrighty, that is it. This is tricky. I will give you that. Don't worry about number 5. You're not being held accountable for that. But really, what you need to do is try to work through these. Use what I've given you as an example. But if you read through the chapter, either as you go or before you even begin, this is going to become a lot less difficult. And then these examples are also going to help you a great deal in terms of how this actually works, right? So go ahead and email me if you have any questions. I'm happy to help whenever you need, and I hope this was helpful. Let's see if I can turn this video off. Maybe not.